Welcome to Networks Professionals.
Hey everyone, and welcome. Today we're going to talk about one of the most important upgrades happening to our world that you probably never even see. It's called IPv6, and it's quietly rebuilding the entire foundation of the internet for tomorrow. To get a handle on why this is so important, just imagine for a second, what if we just ran out of phone numbers? Seriously, no new phones could ever be connected, businesses couldn't get new lines, and all that growth would just grind to a halt. It sounds totally ridiculous, right? But believe it or not, that's the exact kind of crisis the internet has been facing. You see, the original internet, the one built way back in the day, was designed with a hidden finite limit. Every single device that connects to the internet, your phone, your laptop, your smart TV, it all needs a unique address, kind of like a phone number. And the system that hands out those addresses, well, it was built with a limited supply. So that original system, which is called IPv4, had about 4.3 billion addresses. Now, back in the 70s and 80s, that must have seemed like an impossibly huge number. But let's be honest, nobody could have predicted a future where pretty much every single person has multiple devices, and our homes, our cars, and even our coffee makers are all clamoring to get online. And so, here we are. We've officially hit the wall. The global pool of those original IPv4 addresses is basically empty. And that's created this huge bottleneck, forcing us to use these really complex, inefficient workarounds just to keep the lights on. It's been holding back innovation for a while now. But hey, don't worry, the pioneers of the internet actually saw this problem coming from a mile away. And the solution is here, and it's called IPv6. Now, this isn't just some small patch or a quick fix. Oh no, this is a complete redesign of the internet's address book, built from the ground up for a future that is, for all practical purposes, limitless. So how does it pull this off? Well, the real magic is in the architecture. IPv4 used what's called a 32-bit system for its addresses. IPv6, on the other hand, uses a 128-bit system. Now, I know that might not sound like a huge jump, but when you're talking about binary math, that leap creates an absolutely mind-boggling explosion in possibilities. And what's the result? Well, you're looking at it. That's 340 undecillion available addresses. That number is so astronomically big, it's hard to even wrap your head around it. Here's a way to think about it. We could assign a unique IP address to every single grain of sand on planet Earth, and we'd still have basically the entire supply left over. The takeaway here is simple. We will never, ever run out of addresses again. But here's the really cool part. IPv6 is so much more than just a bigger address book. It comes with some serious built-in upgrades. You can almost think of them as superpowers that make the internet better, faster, and way more secure for every single one of us. Okay, so we've already covered that massive address space, which is, a huge deal. But IPv6 also fixes some really old, nagging problems with the internet. It gets rid of this clunky workaround called NAT. It helps data travel more efficiently. It makes it way easier for our devices to get online. And it builds security right in from the very start. So let's quickly break those down. Okay, first up, saying goodbye to something called NAT. Network Address Translation was basically a clever hack to share one public IPv4 address among lots of devices, like all the gadgets connected to your home Wi-Fi. The problem is, it complicates everything, and it's often the culprit behind those frustrating lags in online games or choppy video calls. Because IPv6 gives every single device its own unique public address, it allows for direct, cleaner connections. And that means a much smoother experience for all of us. Then you've got this awesome feature called Stateless Auto Configuration, or SLAC. The easiest way to think about it is plug and play for the internet. With IPv6, a new device can pretty much give itself a valid address the moment it connects to a network. You don't have to wait around for some central server to hand one out. This makes setting up everything from your home network to a massive corporate one incredibly simple and fast. And this one is huge. We're talking about security. With the old IPv4, security features like IPsec were kind of an optional add-on, something bolted on after the fact. With IPv6, support for IPsec is mandatory. It's baked right into the protocol's DNA. This gives us a much, much stronger foundation for authentication and encryption, making the entire internet fundamentally more secure from the ground up. So when you put all of these pieces together, you start to see why this upgrade is just so critical. It isn't just some technical fix for nerds to get excited about. No, this is about laying a new, stronger, and unbelievably larger foundation for everything the internet is going to become in the decades ahead. And this quote right here, it just nails it. It really is all about that foundation. I mean, think about the explosion of smart home devices, or the Internet of Things, or technologies we can't even imagine yet. None of that is truly possible on a global scale without this upgrade. IPv6 is what ensures the internet can keep growing and evolving, totally free from the constraints of the past. And that really leaves us with a fascinating question to chew on. For decades, we've had to build the internet around workarounds and limitations. But now those limits are gone. We have a truly boundless digital space to build in, to create in. So what comes next? The possibilities, for the first time, are truly endless. Thanks for diving into this with me today.
Thanks for watching.